Hey, Michael Chow here, and in this screencast I'm going to be doing a live translation of an analysis from R into Python. I'm doing this as part of a series of translations in order to better understand what some of the similarities and differences are between how people approach data analysis in these languages. And the reason I can do so many translations is twofold. So first, the project Tidytuesday, which every week releases a new data set that people can analyze and share on things like Twitter to learn from each other and to see what different approaches people took. The other reason is because Dave Robinson has put all of his analyses online, and usefully he also has screencasts to go with all the analyses. So this is meant to be a useful side-by-side comparison so you can see how people approach problems. So you can also watch his screencast to see how he did things, and this one to see what they look like in Python. All right, so let's get started. I glanced at the script he uses just to see if there are any nasty surprises. And the answer is maybe. So I noticed there are some sparse matrices and also there's some lasso regression with cross-validation. We'll see how that goes. I have a little bit of familiarity. I also read a tiny bit on it, so hopefully nothing terrible happens. All right, so I'm going to go ahead and get started. So I have the his original R script here. I'm going to open it using Jupytext, so I'll open it as a notebook. Sure. And then what I'm going to do is I'm going to copy it, so I'll duplicate it here, and this will be my Python version. I'll be using a tool I'm developing called Suba, which is a port of dplyr. All right, so from Suba import this, and then I'm going to switch over to, oh shoot. You know what, I actually did something really common that I often do with Jupyter, which is I duplicated something and then I changed the thing. I changed the original when I meant to change the duplicate. All right, so this is better. So the R one's on the right and the soon-to-be Python one is on the left. All right, so I'm going to delete this. I'll be using R cell magic to execute the R code. Okay, this isn't, we can do this. So import rpy2. I've had to look this up every week. We'll see if I can do it. rpy2 dot interactive, maybe? Oh, that's unbelievable. I can't believe I got that right. Oh, no, that's not right at all. So I'm going to go and look up the name of this. Let's see. So here, .ipython. Okay, so hopefully I'll remember next time. Okay. So now we have our cell magic loaded. This seems scary, but we'll see what happens. I also updated my pandas version to pandas 1, which in light of this warning could be a terrible mistake. We'll see. Okay, so this read in the board game data. Let me just make sure. I'm just going to print it out here just to check real fast. All right, so great. It's a tibble. This isn't the nicest representation. We can use show grid for it. So from qgrid import show grid. All right. I'm gonna output the board games data frame from R, and then I'm going to show grid it below. All right. This will probably, has a lot of columns. So we have to do the classic thing that I forget every time. I think it's grid options, force fit columns, false. Yeah, so grid options, force fit columns, false. All right. So that's better. I pressed Command-Shift-D to go into single document mode so I could just view this table. All right, so it's got a ton of columns. I'm going to jump over to the Tidytuesday descriptions just to see what's in here. All right, so comes from the Board Game Geek database, 90,000 games, ratings. This thing has a data set, and there's a 538 article on it. Oh, since we're translating, I won't worry too much about actually the article. I'll just go straight through Dave's code. Okay, cool. So there are all these variables. You know what? Why don't we just go ahead? Since we're doing a translation and not a novel analysis, I'm just going to go ahead and make sure I faithfully reproduce things. So comment this out. I'm going to import pandas. Get rid of this. Let's see. So this will be pd.readcsv, works with the URL. I'm going to hold this. It looks to me like, oh, not an arrow. Looks to me like Dave is planning to, I guess I noticed this with the lasso, but lasso regression, there's a holdout set, so maybe he's doing he's gonna train and then test a model. Okay, well, so this is pretty easy to do. This just means his holdout set is just things with game ID divisible by 5, and everything else is in his training set. So we could do that. Let me import. I'll just do this one in plain pandas. That could be a fun challenge. So, but what I am going to do is I'm going to import the underscore, which I sometimes call Su expressions from Suba. This is a lot like a lambda. So with this, we could use something like this. Game ID. Oh, I forgot how to mod in Python. Is it just the %? Yeah. So, okay, great. So game ID mod 5 is 0. Right. Oh, this is a big data set. No, it's pulling from the URL still. But let's check just to be sure. So .info, 10,000 entries, nothing to cough at. Let's see. So notice that I can filter using this lambda. So expressions, one handy thing is that they just let me delete this lambda. All right, so that works. And this is because pandas is really good at handling callables. Like if you have a function, it knows to run it. And these Su expressions work a lot like that. Just to illustrate, so they operate like a lambda as if we did this, but they're made to be transparent so you can see what they're doing. And this lets the package I'm working on, Suba, decide the best way to run it. So for example, Suba can generate SQL queries, things like that, and these expressions, which are transparent, allow for that. All right, so we have this. Let me just show you this really fast. So you can see this is essentially this expression broken down into an abstract syntax tree, or kind of like you could think of it as a special representation of these operations. All right, so we've got that. This board games raw, game ID mod 5 is not 0. Okay, cool. Oh, this is gonna not be good. So, all right, so we've got that down. Let's see. So now we'll go to the EDA. We also have this. Oh, that's not gonna help. Sorry, you can pop out a table of contents with a Jupyter Lab extension We're already kind of short on space though. All right, so board games. Let's make sure this all runs. Oh, needs to be an R block. Oh, that's not good. I'm gonna have to probably look and see. So data must be a data frame. Something terrible has happened. I'm gonna go one by one. Okay, that's good. That's not good. Did we import GG? Well, ggplot should be count year published range. This seems pretty standard. Oh, you know what? There, it looks like there's a typo here. Looks like it's missing a pipe. Great. So what happened was because this wasn't being piped into ggplot, so this is equivalent to if we said like, hey, you temporary variable, and then if we ran ggplot like this, that's what that's doing. So the pipe is just a convenient way to let you do that. The issue is that without this, it thinks you're just running ggplot without that first argument. All right, so put that back in. All right, let's uncomment things now. I'm also going to move them into their own cell, which Jupyter likes a little bit better. So now we can see them each. Oh, what did I do? Oh, I need these R blocks. The other thing is with GPText, we could have this just run them as R blocks by default, or use the IR kernel, which is an actual, rather than here where we're running R from Python, you can actually just run the notebook from R using something called the IR kernel. Okay, great. All right, I think we're in. So he did a rapid set of visualizations. I think this is a really useful practice, and something you can see in his videos too, is that he's quick to visualize right out of the gates. All right, so I'm gonna do the same and delete these. Remember to put the pipe in. I'm just gonna run this in, never mind. Let's just get to it. So board games here, and then he's taking account. So the way you do it in pandas is you do something like this: publisher, yeah, dot size. So or dot count. So there are two methods that I'll show you, and then we need to reset. Oh wait, no, this is this is tough because let's see. No, this is right. So, and then we reset the index and don't drop it. Cool. So now for each publisher, we have a count. I'm not sure we can name the size, so we'll just have to let's just do it here. So I'm gonna put this in a let's stick with the syntax we've been using, which is something like this. Okay, there we go. And then we're gonna rename there is a, I think, slightly easier way to do this. I could see the size. I think that we might be able to set a name somewhere, but this works too. So, all right. So that's good. He also sorts it, so that'd be dot sort values n, and he sorts it in descending order. I can't autocomplete. Let me see. board games dot. I'll just say I just want to check the arguments. I think it's just the word ascending. Yeah, ascending equals false. So ascending equals false. Cool. It's a lot of work, but we can do it. So just as a reminder, if we were using suba, we could just do that directly. So from suba import count. We could do like count board games dot group by, or actually it'd be count board games by publisher. So gives you the same result. Okay, so we'd need we actually need sort equals true, like in the dplyr code. All right, so now I'm going to import from plot9. Okay, so plot9's basically the exact same as ggplot. What's happened? Oh, he was just glancing, actually. So here, I think he just wanted to see basically like this. He wanted to see, oh, what's the most popular publisher? All right, so, but now let's make this next plot. So here he's counting year published. We could do this again. We could also do, so actually, sorry, another thing we could do is we could do value counts. I think year published, let's double check. This would be if we needed, this one's more general, you can group by multiple things, but if you need to count a single column, this works well. Year published. There's also the actually the crosstab function, which I probably should have used. So reset index. That's fine. Okay, so here's that. So now we can either give it a temporary name since he uses it in a pipe, or we can just pass it straight into ggplot. Let's see, so just go ahead and we do this kind of crazy thing, which is ggplot lets you pipe it in using this syntax. So here published. Notice that that's the worst. So ideally I'd want year published to actually be the index, which makes a lot more sense to me. And then n. All right, let's switch to, we've shown how to do it in pandas. Let's switch back to count, suba count. So board games, year published. We can also do this piping syntax. Yeah, we'll see. I might great. And we can view it like this. I think he sorts it. He sorts it here. So we can do sort equals true. He probably wanted to glance at how many were published per year before he plotted it. And then, so this is just ggplot syntax. Cool. So we got it. Let's see. So now, here so it looks like there are a lot. Board games are really coming up in the world. Histogram of average rating, just to see how they're distributed. Great, so that's pretty straightforward. I think, again, we can use this piping syntax. It's almost the same. I just have to put the column names in quotes. Okay, great. All right, let's keep going. We're making pretty good time. I mean, I wouldn't really know, but it feels like a good clip, so keep this momentum. All right, so here he's getting certain ones, games that take between 5 and under 1,000 minutes. I'm kind of curious about games that take over 1,000 minutes. I'm guessing the way it happened is that he probably originally didn't have the filter, and then he saw there were some really extreme values, and he put the filter in, which makes sense. So, all right, let's do the same thing. Again, let me try to do the pandas. It's pretty straightforward. So we can, rather than a filter, we can do that lambda max playtime is greater than 5. Here we can do two conditions. We have to put it in parentheses because of how Python handles these ands. I also can't remember if it's 1 or 2. I haven't been doing a lot of these in Python, or enough, I guess. So let's see, we'll comment this out. I think it might be 1. Yeah. Cool. Again, I'm going to take this out because I'm using Suba. So don't need the lambdas here. All right. Okay, we'll take this filter. The one downside of this is that, notice this approach you can uncomment the row, and that's really handy. We could actually do the same. So I'm going to do .loc and then put the criteria here. So this is a lot like the filter statement. All right, so I'm going to go ahead and leave that in because we could do that with Suba. We just need the underscore and these things. All right, ggplot, we just need to put in strings. One really cool thing about plot9 is you can actually have these kinds of expressions that it will evaluate. Oh, that's no good. Again, we'll do this. The one kind of funny thing is that, sorry, so this is a sequence from -2 to 4. Let me double check exactly how that plays out. I think it's by 1. I think it's just -2, 3, 4. Or yeah. So you can also do this in R. Should work. Let's see. So although he'd have to, yeah. Anyways, so this will be a range. In Python, we need to do one more since it doesn't keep the last number. The other thing is that we actually can't do, we could do something like this, maybe. I'm going to double check that. Let me grab this just to make sure that works. I didn't even know I had NumPy imported. Oh, that's actually maybe a bad thing. I bet it was imported from that plot9 blanket import, or that's pretty mysterious. In any event, it's imported now, so we're really living the dream. Okay, so that works. I'm going to keep that here just in case something else breaks. That's not right. 2 to the, yeah, let me, oh, that's not, oh, this isn't, so that's not power in, oh, that's not fun. So I would bet that there's an np.power, or let's see, I can't remember how to do negative integer powers. That's pretty surprising. So let's see, np.power, yes. Let me double check. So raise each base in x1 the corresponding power next to. So it should be the same. Oh, okay, I'm gonna have to Google it. I haven't hit this in a long time. Or maybe ever. So let's see. Let's keep going. Let's figure out a way around this. You know, I bet we can, maybe as a float? Let's see. Okay. All right, let's get to the good stuff. So I'm gonna try to do it as a float. Yeah, that works. So, yeah, okay, that makes total sense. So NumPy, I think the point is that NumPy, if raising integers, I don't know, if raising something to an integer, it's an issue of probably coercion, but with a float, they know, say, like, that the output's a float or something. In any event, it's surprising, but I can kind of see the reasoning. So I'm gonna do, I could simplify this to mp.arange, and then I can make this actually a float, and that should be fine. See what happens. Oh, this is again the wrong thing. Cool. All right, so that's looking pretty good. It's kind of a funny scale. Oh, that's also not right. Double check, see what's going on. Max playtime divided by 60. Let's check this again. Okay, so we've got the range. For some reason, maybe the way it shows breaks is different. Let's oh, but we set a bin width, so it's a little bit surprising. Does he use a scale? Yeah, he has a xlog 10. Uh-oh, so it's no good. So I'm not sure. I'm gonna take this breaks out really fast. Okay. Oh, maybe I max playtime greater than 5 and oh, I'm sorry. So max playtime less than 1,000. I thought it might have been something to do with the plot. So I'd actually accidentally filtered under 100 rather than 1,000. All right, so it's pretty similar. So there's kind of funny thing going on with these minor lines, but it's pretty good. So let's get rid of, need this. This is the next plot. Let's see, this should be a quick one. Going to do the Suba thing. Count year published. Change to here. Yep, do the ggplot thing. All right, and then again, we just need to put these in strings. So close. Oh, one last thing. Okay, yeah, looks good. Let's keep moving. All right, so this looks a little more involved. I need to, before next time, I'll definitely need to look up just how to set the R kernel. So, Doctorlive should be, let me check my R. Let's do remotes install github dgr2/doctorlib. All right, so we'll get that installed. While we're doing that, I'm just going to glance at what this code is. It looks like He's grabbing a bunch of the columns. He's gathering it, meaning he's turning these from columns into rows. He's filtering out the NA values. And then he's separating. So this one means that in some of these values it's kind of like they've packed some values into the data frame using commas. So let's see. We can run this just to illustrate. So I think up to here is a good place. I'm gonna put this here, and then I'm gonna comment this out really fast. So notice how nice it is too that we can run things like that. We can just comment out, even assigning to a variable, and just print it out really easily. So the key is that the value, notice that here it's like, there's actually information encoded in here, like type, family. Yeah, the family of the game is like Asian theme, Japan, this word, tiling. But these are packed into this one column with commas, so we need to unpack them. What separate rows does is first it's easier to understand maybe by the function separate. So so new call. I think this is how you use it. Yeah. Oh, I need to do multiple. So the key is that it can say split all these comma values into new columns, and these are just the names of the new columns. So notice this one, which has multiple labels, it's split by column and then put them into each having their own column. Separate rows basically takes each of these, and whenever there's a value, it gathers it, so each of these becomes a new row. So boom, boom. Actually, let me just show by oh, how do I get the first row? That's embarrassing. I think we do that, but it's not the, oh, okay, that was dumb of me. Let's see. Oh, I think let's see. So wait, sorry, I accidentally had to separate rows. So all right, I'm gonna grab just the first one row, and then I'm gonna separate. Notice that so we just have this one, and it's one row, 6 columns. Let me and we created essentially two new columns with values, A and B, which are 2 of its tags for the family of game. So separate rows, what it does is rather than putting it in columns, it creates a row for each of those values. So now Germany Valley Games and or classic line, whatever these are, will be their own. Nope, I did something real bad. All right. Now notice it took these, it put them in their own rows. So now each of these family values for this game is a row. So rather than having one game per row, it's now game by value, essentially. All right, so let's get that there. This is probably going to be a pretty big data frame. Yep, 77,000. Let's do a range ID. That didn't work. Okay. All right, so now notice that it's sort of like you have all these features per game and multiple rows per game. How long do we, oh gosh, okay, we're gonna make it. So this is gonna be a little bit tricky. The reason is separate rows isn't in Suba yet. We do have though separate, so it should be okay. All right, so let me first do I want to do the pandas way? Yeah, let's just do it. So boardgames.loc grab each of these. These need to be, so the first Argument to loc is the rows, the second is the columns, so let's put these in strings. I might do some formatting to make it not take up so much space. Nah. All right, so this is loc. Let's just go to there for now. Okay, great. I'm gonna print out, not above, probably below. Let me move these into their own cell, and just so I can print out categorical values. That wasn't its name. Variables. Great, so there we have it. Gather. This is basically just the pandas melt function. So melt by, let me think about this. So the trick is that these will be what the melt function takes as ID vars. That's its first argument, I think. I can't get the autocomplete. I'm almost positive it's called ID vars. We're going to find out. So here, rather than using a negative, we just include them by name. And then I'm guessing it's called measure vars. I'm just going to go boardgames.melt. Sometimes autocompletion gets a little funky. ID vars, value vars. Yeah, that's fine. ID vars. I'm going to put these on their own lines. Value vars. All right, so that's no good. Oh, I'm sorry. This is he chose everything except for group ID and name to be value vars. In melt, you can actually leave these off, and that's its default behavior. So it says keep game ID and name as they are, and then melt all the other columns. So for each variable, like family, let's see. So now for each game ID and each name, you have one row per column of these different variables, like family, mechanic, and these used to be columns. All right, so you can just move this there. The one trick is that he named them type and value. We can do that with what's called var name. Var name. Yep. Var name equals type. Cool. So notice we've got the same setup, although his is sorted by games, and he also did the separate rows, which is going to be a real doozy. So all right, we're going to use again loc, and then we can do not na value. Oh, all right, so filtered out a bunch of rows. Let's see, this is 36,000 rows. It used to be 41,000. So we're getting rid of NAs. Melt might have a argument to actually, nope. All right, I was thinking melt might be able to drop NA rows. All right, and then we did that. Okay, so separate rows is going to be a little tricky. Basically what we need to do is we need to split value, and then we need to put each of those entries on their own rows. I think the easiest way to do it is, let me think about this. It's one of the string methods, so probably something like, I'm gonna dot string dot Oh, autocomplete really isn't working out right now. So I think it's split. Let me. Oh, this needs to be value dot string dot. Yeah, this is the worst. So yeah, I just can't get autocomplete. So I'm gonna just do dir, the classic. I think so there are some different ways to do it. I think split works well. There's also one. There's one that will return a data frame actually per row. Anyways, let's just split by comma for now and see. I believe split by default uses a regex, which is a little bit funny, but let's go for it. And I think if we do expand equals true, oh, that's going to be too slow. So this is the one that creates a data frame per row, but actually, oh, there we go. So this is going to be nuts, but it's exactly what we need. So, all right, let's just go for broke. Now we're gonna melt it. So it did split, like when we looked at separate before. Now we can melt. Let's just do that here. I'm gonna do it real sloppy and then clean up in a sec. So melt dot. Oh, you know what? Why did it? Let me double check. Categorical variables. Did it take out the names from categorical variables? Yes. There's a problem with what we had. If you look, it's not the full data frame expanded. It's just that one column. So value, which makes sense. Let me let it run and then I'll show you. Okay, so this is just the value column. This is just these splits right here as a big data frame. So what we can do is we can melt it. Oh, there's a simpler way to do this, but yep. The one trick is we don't want, what's variable 0? It's using the index as the variable. Or maybe it also, okay, so we're gonna have to basically, maybe we rejoin it in to expanded. So let's set expanded game ID equals categorical variables. Just be consistent. Here, probably shouldn't have taken the time to reformat. And then now we can do expanded dot melt and keep game ID. This is a pretty slow approach. The problem is that we basically exploded the data frame, and now if you look, we have 18 million rows. That's definitely not ideal. So maybe I actually can't think of a great quick approach. What we could do though is we could iterate over the data frame, because that's pretty quick to do. All right, so now notice we have these as a list. And what I'm going to do is I think that the best thing is probably to join with game, like create a big series with these flattened, and then have the game ID on the index or something. I'm gonna Google though, flatten a series of lists pandas real fast. I think there might be a good method for it. Let's see. Oh, but we'll have to apply series. That'll be slow. Yeah, that's the problem. So this will add them. That's probably not the best behavior. All right, so here's what I'm gonna do. I'm going to I'm gonna just, let's see. I will also want to get the game name in here, but let's see. Here's what we're gonna do. Set index game ID. This is kind of silly, but now we have it. Oh, yeah, that's right. And then so we have split values here. Okay, and then I'm gonna just do a good old-fashioned loop for game ID val list in split values. What's the best way to do this? Let's just do list out.append a tuple with game ID and val list. I'm gonna do val for val and val list, and now I'm gonna do dot extend, and I think this actually has to be a list. Okay. How do I iterate over the index and the series? Pandas iterate over index and value. Iter items. I wonder if there's a better way to do this, but all right. So we've got that, and then now we can just pd.dataframe it. How do we? There's a way to assign names, I think. I think it's this. Let's double check though. Just this placeholder. Cool. So he names it value. Okay. So I think that gives us what we want. It's a pretty tough solution. Separate rows is pretty handy though. So, all right, and then I'm going to merge back in. I'm gonna name this unseparated variables, and then unseparated variables, and then I'm gonna call this where's its name? Categorical variable. Categorical variables equals. What we'll do is, I'll say melted values, and then categorical variables will be, I don't need to do something so fancy. So we'll just merge it. pd.merge. Oh, you know what? It doesn't matter. This is exactly what we need. So I think this is what we want. Let's double check. Game ID value. No, he's got, yeah, so he got type out also. so so we either could have kept that on here, like put it in the index, for example. Or let's just join it back in with the board games data. So let's see, pd dot merge. Oh, you know what? Let's just do it here. So out dot merge. I'm going to put these in quotes because it would be nice to be able to comment out some of these lines. pd.merge with board games, just so we can get type out. I'm actually going to do game ID type. Oh, this is a lot of work. So, and then by will be game ID. How will be left, just in case there were some board games that actually didn't have any data. Oh, the worst. Type. No, it's in unseparated variables. And then we got to rerun this. Oh. Game by. Oh, it's on in pandas. Oh, something's beeping at me. Okay, but bad news. So he had 77,000 rows. We have a lot more. Oh. Let me think about this. So something terrible happened, and we now have too many. Oh, we need to join on. Shoot. So we do need to keep. So basically, what happened is he melted. So he had all these. Basically, board games has. I'll do it here. From QGrid import. Show grid. Let's do our cool thing. Oh, that's a bad sign. So show grid doesn't seem to want to work with. I don't know why. It's pretty weird. So anyways, we can just look at this. So there are all these columns like family, I think category. They all have comma separated values in them. He melted it so that these are now on rows. So something like family, rather than being a column, is on rows, and then categories on rows. We need to know that for the splits that we did. So when we split out comma separated things, we need to know which column they were in. And that's in this unsep variables. We set game ID here. That's great. We also need to set we could set it in the index. We need to know the type when we create this giant data frame. So the thing is, though, whatever, let's just, I think that we can actually do it like this. I'm not sure if this will work, but YOLO. Yeah, it worked. Oh no, okay, probably here. I definitely need to do some formatting. All right, we don't have to join anymore. So what I did is I pulled that column out of here. I put it in the index. I used iter items, which lets you iterate over the index and the value. So index and value. And then I unpacked the index here. I'm sure there's a better way to do it. Someone much smarter than me probably knows how. So Anyways, now we have all these values basically from um, category, family, unpacked, and we can use them. Oh, we could have used, we actually could have, Suba has the function unnest, which, as far as I know, would have done that just very fast. So, it's my bad, I guess. Let's just check. Now I'm too curious. So, basically what I'm saying is that we could have done unsep variables dot assign and essentially just done this. Where do we split? Here. So let's assign this to a row. Result. I'm going to use Sue. All right, so notice we have these, and then let me just double check out of curiosity. If this works, I'm just gonna cry tears. So we can use the piping syntax. Why not? Okay, it didn't work. I mean, I feel it should have, but it doesn't. So Suba used to work on lists. I think now with the pandas update, I have to change some things. Let's see though. Oh, what's happening? You know what? Yeah, so it does work. I think I have an issue open for this. It works. It's a little bit slower than I think I'd want it to be, but it is the right number of rows. So to be honest, I think for the time it could have saved us, even the slowness in unnest is worth it, because clearly we can do it by hand, but who wants to do that? So this is, to me, a much better. I wish I had just done this earlier, because even if it took a little longer to run, it was way more convenient. And I'm going to drop, should get rid of this value, this intermediate thing. That would be something like, it's not great to be mixing Suba and this chaining, but it works. So drop columns equals value. All right. If we wanted to, we could just use the unnest rather than a pipe just out here. That's dumb. Let's just do this. So, all right. It's pretty ugly, but gets the job done. So, in a sense, I did some early operations and then I piped it into Suba. All right. Yeah, it definitely takes more time. In the grand scheme of things, life is so short that I wouldn't have wanted to code the faster manual solution again, probably. Let's put that here, though. So, categorical values. Great. So one way to get categorical values, a much shorter way. I think I have an issue open. There are ways to speed this up quite a bit. I haven't even really given it much thought. Okay, so what Dave did in 2 minutes, we've now achieved. Let's keep moving. This is gonna be, we could do it. We just need to go real fast. So, let's see. I'm gonna sign this. That was a good issue to revisit. I remember thinking about it a lot when first working on Suba. All right, so now he's just counting them. Pretty straightforward. Here he dips into drlib. That's his personal library for doing some things. It's usually to do a little bit of ggplot stuff. So let me show you what it looks like. Okay, so the plot in R will be we'd need RStudio probably to see it. Luckily I have it. Is this? Yeah, let's run this. I think it's right here. So run to here. In the meantime, let me. Oh, I'm gonna need to fix that error though in his code. See what happens. Yep, there it is. So here we are. Fix this. Then hurry and run down. In the meantime, I'm gonna look at. So this looks like he's grouping by type. That's gonna be potentially pretty slow. In pandas, he's grabbing the top 10 within each type. So let's see here. He's plotting by. There's a lot of stuff. So his facet is type. So where is the facet even? Facet wrap? I think so I think one challenge is we're gonna need to look at the RStudio because the plot is too compressed, so we can't see what's going on. All right, so looks like in his facets are the types are mechanic, category, artist, designer, family, games. The reason he's using his library is because he wants to reorder within each of these facets the levels. So that's not super easy for us to do. Let me take a look. All right, so here. We spent so much time on that last problem. It's almost better to maybe stop briefly. This problem will be, it's quick to do his implementation, but I don't even know if it's worth it at this point. Let's all right, let's do this one and then I'll save predicting for another video. So basically here he's counting. This is fine. We'll just use Suba for it. Here we go. Count to the pipe, the equal sign, and then I need to precede these with an underscore. The big advantage of Suba here is that we're counting by multiple columns. All right, so categorical counts. Great. So these are just counting all the types and their values. This is so a lot of uncredited designers in the designer column. All right, so that's that. We won't use drlib. So we don't have top n implemented, but it's just getting for each group the top values based on n. So it's for each type, like designer, mechanic, each of those columns in board games that we melted, what are the top 10 most common values they see. So what we can do is let's just do this. Suba import group by ungroup. I'm going to put this in parentheses. Great. then categorical counts, put in the pipe, use suba. The trick is, if we wanted to get the top 10, actually this is pretty easy to do in pandas. Let's just do it like this. So we can do this in one line. I think we can do, oh, maybe not actually. Let me think about this. So how do we get the top 10? I mean, there's an easy way using something like maybe apply, but wow. So one thing we could do is we could do group by type, mutate. You know what? I'm gonna have to think about this. How would we get the top 10 out? So we could do something like yeah, I'm not sure. I without like a pretty complex lambda, I'm not totally sure what we would do. I think yeah, I'll need to look into it. I think basically, well, so if we think about it like categorical counts, basically so we could do something like this, group by type dot apply, and then in our apply we could do something like lambda d, because it takes the full data frame, d dot sort values by n dot head 10 and ascending equals false. No, that didn't work. Oop. Yeah, that worked. So let's do that for now. This obviously isn't very scalable, but we only have a few groupings, so it'll be fine for what we're doing. All right, so let's just do that. We'll these here. All right, so, and then he's got the mutate. This is not going to be pretty. So here we'll want to actually use suba. I need to commit to one style of piping. So great. Put this here for now. Let's get this mutate going. So put this in like this, and then all right, this is what this looks like. Basically what Dave's doing is he's reordering. He wants to set the levels so that I could show you in the what'll happen if he doesn't. The other trick is that he's using facet wrap. Let's just do this. So crazy things are going to happen. Okay, this is good. This is pretty good experience for Suba though. So figuring out what to build in Suba. So this will, I think, more or less go. Let's see. Looks good. Let's see. Oh, I forgot how to view the lines in. Actually, not sure which line number that is because I forgot how to view line numbers in, is it Control L, Command L? Nope. Oh, here. False, not the yelling false, just the simple Python one. That's a bad sign. Where's this coming from? This is coming out of pandas and ggplot. I bet that type. So type is also a Python function, which I think does not bode well for plot9. I think we'll have to rename it. Let's try this. Mutate type equals type. Oh, that's, I could see how that's not the clearest thing we could do. Okay, and then mutate. Oh, and then change this, change this. I could have just done dot rename, I guess. Yeah, well, we have time. Yeah, so, and the trick is that all these categories had levels that others don't. So like, you know, an artist isn't going to fit in this, their name's not going to be under the family of game. So in a sense, what drlib does is it removes per facet unobserved levels. And the way it does is basically, I think it adds separators. Oh, what happens? It's something crazy. It like adds a separator. Oh, to let it. The other thing is that it wants to let us sort. This is gonna be hard to do. Okay, so wait, let me double check the if facet wrap does indeed. So without any of even the drlib stuff, let's see. One thing I'm surprised about is it seems like, oh, you know what? There seems to be a discrepancy between R and plot9. It looks like in R it drops unobserved levels. In plot9 it doesn't. So that's going to be a hard one for us to work around. So basically, like, there are these levels in these plots that have 0 values, and we'd want to drop them. It doesn't look like facet wrap. Usually free Y. Oh, did he coord? Sorry, I know what happened. He coord flipped it, maybe? Yeah, here. Coord flip. And that's why. Oh. See, so free, I forgot, the argument free Y actually gets rid of all those unobserved levels. So now notice we flipped it and we got rid of all the levels with 0 observations. The other trick now is that, well, there are a couple issues here, as you might notice. So the text overlaps with the plots, and he used his tool to essentially order it. Yeah, we won't focus on that at all. So, so this is probably a small bug, maybe in plot9. The text shouldn't overlap on the plots, and he has a handy function to reorder things. I might implement it Zuba. It shows up quite a bit, so we could definitely implement it somewhere. All right, so that, at least we kind of got started. This isn't a great plot to end on. I think actually yeah, let's see. One thing we do is I won't coord flip it, and I'll change it to make the x-axis free. Let's see. And it's not better, but we can also maybe if I rotate, so theme, okay, axis, x text, I think. Text x equals element. I think plot9 is a very faithful, yeah, element text rotation, I think. Let's see. And then I have to set the h just. All right, it's angle. not rotation, and then h just equals 1. This is just kind of like an incantation you utter to make the text rotate, but it's got the same problem. It looks like there's an issue with text overlapping facets in plot 9. So anyways, we didn't get to the model. That's a big disappointment. We weren't close. So but we did handle some pretty gnarly issues around splitting text fields with commas, things like that. I'll definitely afterwards look to see if there's a better way. If you know of one, feel free to comment. I would love to know different solutions to these problems. So hope you got something useful out of it. And then I'll do another video on the modeling portion in a future video. All right, thanks for watching.